The focus of this lesson is going to be to quickly review solving for perimeter of familiar shapes, squares, rectangles, and for that matter, parallelograms. And then to review, and this should be familiar to us, review the area for squares and rectangles, and just make sure that we understand some of the possible confusion that may exist when it comes to finding the area of a parallelogram. So let's get to work. We know that the basic way, the most basic way of solving for perimeter is simply to add up all the sides. And since we're dealing with the square, we know all sides are congruent. We can see in the square, all sides are clearly marked as congruent. And if we know the length of one side, we know that the length of all sides are also as marked 7 meters. So the perimeter we can simply say is 7 plus 7 plus 7 plus 7. Or if we want to take an easier approach, we can just simply say it's the fact that we have 4 sides out of times 7. We can say 4 times 7. Either way, we're going to get 28. Now don't forget to say meters because we want to label it. Likewise, if we go down to the perimeter of the rectangle, we know the easiest way of solving for the perimeter of the rectangle is just to add up all the sides. We know we have the top and the bottom are congruent, each of 9 centimeters. The right side and the left side are each congruent at 4 centimeters. Another option for us is to recognize that there are 2 sides that are 9. There are also 2 sides that are 4. So we can multiply the 4 times 2 and the 9 times 2 and then add those results. The last way we can do it is simply to add the 9 and the 4, but that only takes care of 2 of the sides. And once we add those 2 together, we can double the result. In all cases, whether I add the 4 sides up, I double the 9, I double the 4, and I add it together, or I add the 9 and the 4 and then double it, I'm going to get 26 centimeters. Last but not least, on the parallelogram, we've gotten used to recognizing that this value inside is of no use to us right now for perimeter. It is not the length of one of the sides. So we're going to recognize that similar to the rectangle up above, we have 2 sides that are 7. We have 2 sides that are 15. So we can simply say 7 plus 15 plus 15. Or we can recognize that there are 2 sides that are 7 and 2 sides that are 15. And then add those outcomes together. Or, similar to the rectangle, we can say that there's a side of 7 and a side of 15. And then double the outcome once we're all set there. No matter how we look at it, we have 30 and another 14. It looks like we have a total of 44 centimeters by the time we're done. So nice and easy. So let's now tackle the area. Looking back at your reference sheet, you know for a square there is a special formula, A equals S, and by the way, S stands for side, so my side length is 7, but it's to the second power. That means we're going to multiply it by itself. So in this case, it's 7 squared, which we know equals 7 times itself. And the area is therefore 49. Now make sure when you label it, you recognize the units are squared, meters squared. That's the area of your square. The rectangle, we have 2 options. When you look at your formula sheet, you have either in formula number 2, base times height, A equals base times height, or A equals length times width. Either way, one of our dimensions, it doesn't matter which is which, one of our dimensions is our base. Let's call the 9 our base. And the 4 is therefore our height. Likewise, the 9 can be considered the length and the 4 considered our width. But once you multiply the length times the width or the base times the height, you're going to get 36. One more time, you're going to label it as square units, centimeters squared. So this is where things can get a little bit tricky, because for a parallelogram, you will also see that the formula is A equals B times H, the base times the height. Now, we want to make sure that we recognize what the height is. That's where this value comes into play. Anytime I see a parallelogram, if I see this side running through the shape, and likewise, I'm going to transfer it out here. If I see it running outside the shape, most importantly at a 90-degree angle, that will always be our height. So that is H. Likewise, if I took this line and brought it outside, it would also be 5, and that would also be my height. That would also be my height. So this is where we're not going to use the 7. The 7 is of no use to us. So to make it really clear, if I were to take, and I'm going to shade this in, if I were to take this triangle right here, and I could cut it off and move it to the outside, it would become that, and I would have this shape I'm going to outline in green that's been cut into a rectangle, and that rectangle is going to have a base of 15 and a height of 7. So it's really important we recognize how to make use of that dimension that either runs through the shape at a 90-degree angle or is drawn at a 90-degree angle outside the shape. And whatever that measurement is, that is your height. So in this case, our base we'll call 15, our height is 5, and 15 times 5 is going to be 75. 75 units squared, in this case centimeters squared. So this is the problem that you're going to have to be really careful of when it comes to a parallelogram. Make sure that when it comes to the area, you're using that dimension that forms a 90-degree angle to one of your sides. That will act as your height. Do not confuse it with the length of the slanted side, in this case the 7-centimeter side, which is one of your outside dimensions that you will use in your perimeter. So make sure you make use of these formulas and follow what I've done here in these notes to answer the problems on the worksheet. There are 6 problems altogether. I think there are 2 squares, 2 rectangles, 2 parallelograms. For each, you will solve for the perimeter and solve for the area, just as I've done for each of these shapes. Thanks.